I want to demonstrate the use of LynxDesigner to develop a REST interface for your application with OSLC capabilities. LynxDesigner is a platform that helps you manage your complete engineering toolchain. In this demo, I will specifically focus on LynxDesigner's model-based low-code capabilities that helps you develop an OSLC interface for one of your engineering applications. You do this by first modeling the product information you need to expose, then defining your OSLC services for your applications based on this information model. I will demonstrate an end-to-end integration use case where we will introduce the capability for a requirements engineer to create a traceability link from a requirement in Polarion to a change request in JIRA. We support this use case using the OSLC approach through the use of delegated user interfaces. In such an approach, Polarion will embed user-oriented pages from JIRA that allows the engineer to search, select, and preview information. All this without the need to ever synchronize or copy data from JIRA into Polarion. I will demonstrate how to create such an OSLC interface for JIRA, since such support is missing. Polarion already provides such support, so we need not do anything on that end. This demonstration is then a typical illustration on how to develop OSLC support for any application that has a REST API. In this demonstration, we will not go into all the details. We instead want to give you an overview of what it takes to develop an OSLC interface with LynxDesigner. I will hence assume you are knowledgeable of the REST API of your application. But let's quickly go through the JIRA API we will be using. On this link, you can find the JIRA API documentation. Here you can find information about all the REST calls you can make. We are interested in making calls to search for issues, get a single issue, search projects, get a project. Let's just take search issues as an example. To search for issues, you can call this relative URL. And these are the different queries you can send to configure your search. Notice that these are relative URLs. They are based on a base or site URL, such as this one. This particular URL represents JIRA Cloud for our own LynxWork site. So let's experiment with the URLs to see how the response from JIRA looks like. We will use Postman for that. Here is the complete URL for the search, and these are the parameters I chose to use for this request. When I press send, you will see here how the response from JIRA will look like. We will come back to that soon. When it comes to authentication, JIRA recommends the use of OAuth 2. We can then read further about this using the following link. If you dig into the details, you will see that you will need to configure these set of parameters for your particular site on JIRA Cloud. I will here assume that you have already extracted this information that we will use later on. Now, with this knowledge of the application, we are now ready to develop the OSLC interface. This is an overview of the steps it takes to develop the OSLC interface for any REST-based application. We start by modeling the product data. Then we model the toolchain, in our case, Polarion and JIRA. Then, for the JIRA application, we want to design the OSLC interface. This entails the following sub-steps. We model the needed operations and the connections to JIRA. Then we generate some code. Then we will need to write some small pieces of code to translate the JSON responses from JIRA. And finally, we deploy and run the application. Once in place, I will show you how to use this interface to help the requirements engineer create the traceability links from requirements in Polarion to JIRA. So let's get started with modeling and developing in LynxDesigner. So the very first step is to create a modeling project. This is where you will manage the model of both the OSLC interface and the information model. In this project, I now create a toolchain model. And I choose the LynxDesigner viewpoint. Next, I should design the information model and define the type of resources my applications will exchange. This can be done in the same model, here under the specification diagram. But in this case, I don't want to develop the model from scratch. I will instead import the standard OSLC domains, which I've defined already in this project. In our case, we will be working with the change management and requirements management domains. So I want to visualize these by dragging and dropping these domains into my local model here. And now you can see the types of resources available, their properties, and the relationships between them. Once I have this information model, it's time to model my applications. So now I go back to the toolchain diagram where I define my applications. I first create the JIRA application. I will also create the Polarion application. We will not design the Polarion application since Polarion already supports OSLC, but it's nevertheless good to model your whole toolchain. So just for completeness, I will model the fact that Polarion exposes requirements resources. Let's go back and focus and dig deeper in the design of the JIRA OSLC services now. So now I will create services for change requests. I choose query capabilities, selection dialogues, and I want to be able to read and update change requests. And now I can see these operations I defined here in the diagram. You can configure these operations further from the defaults through the properties of each of them. In particular, you can see the URLs and configure them for both the instances of change requests, but also for their operations, such as queries. I will do a couple of small changes. In particular, I want to change the instance ID of a service provider to be project ID, since a project corresponds to a service provider in OSLC. Here, I can configure the application. In particular, I can control the URLs of the server. At this point, the model contains all the necessary information to define the OSLC interface. I can generate complete code from that. But then I would need to develop the remaining code to connect to the source application, JIRA, and obtain the needed information. Instead of doing that, we will model the REST connection to JIRA. LynxDesigner can then produce the necessary code to obtain the data from JIRA. I will model this as a REST source, and I will then configure this REST source to match the JIRA settings. This is the base URL that we found from the documentation. We know that JIRA produces JSON, but we know that JIRA doesn't have a schema that specifies how the data looks like. Instead, we will ask LynxDesigner to analyze sample data and construct Java classes from these samples. These classes will become very useful in handling the information we get from JIRA, instead of directly dealing with JSON content. So we set the source type to instance data, and we have the schema path where the data will reside. We will now connect the services to the source. As we saw in Postman, the URL pattern for the query, we will take that and we will place that for this connection between making a query, and we know that the source type will be issues. I will also connect the web service that reads and deals with a single change request or issue to the same source. And again, based on my API documentation, I will know that the URL to get a single change request will be this one. And the element type being returned is issue. And finally, I will connect the service provider to the same source. And the service provider corresponds to a project, so I will have the relative URL to get a set of projects, and the return type will be projects. And to make it all work, we need to provide parameters for OAuth 2 authentication. So I will add OAuth 2 authentication to my configuration here, and these are the OAuth 2 parameters that we've identified as necessary. I won't have time to explain exactly how to obtain these, but they should be available in the documentation, as we showed earlier also. We save the model, and now we're ready to generate the Java project from this model. The generator has created a complete new Java project. In my configuration, I specified where the Java project is to be created. So I will now import that project into LynxDesigner. LynxDesigner produces a Java Maven project, so I can use any IDE to develop this, but I can also use LynxDesigner for that. I import it as a Maven project. And now we'll switch to the Java perspective to work with that project as a Java project. Before I forget, we will create this folder where I promise to save the sample data from the JIRA. So I will create the folder, resources schema. And I will then place some sample JIRA data in that folder. I've obtained this data from the Postman request, and here I've saved them as a file, so I will copy these files into this folder. And then LynxDesigner will use these files to produce some Java code that corresponds to these. Now I have an almost complete web server being generated. Here you can see, for example, the classes that deal with the web requests, in particular change request here. And here you see the different methods that, for example, returns a change request upon a web service request. Here is for the small review. That's the operation for small reviews. Or to deal with the RDF requests for that same change request instance. Or also, if you want to update the change request, then we will have the method generated to deal with that. We will not try to understand all these methods. We only need to decide in the code how data from JIRA, in our case an issue, translates to a change request, which is what I modeled my interface to expose. This is done in this class, issue to change request. There are two methods that I need to implement here, namely transform resource. How do I translate an element issue that I got from JIRA to a change request that I'm expecting at the interface? And transform ID. How do I translate the ID of a change request, which corresponds to the URL I chose to represent at the OSLC interface, with the ID of a JIRA issue, which also translates to the URL needed to get an issue from the JIRA API. LynxDesigner will do the rest. It will provide the code that connects to JIRA and get the issue as JSON. It will also create an issue instance from this JSON. So I only need to complete these two methods to return a change request given an issue instance. Let's add some code to the transform resource class. I will not explain the details of the code I'm writing here, but I hope you can see that I'm trying to construct a change request instance given an issue instance. I am also taking advantage of the method and the methods in the issues class. And this class was generated using the sample data that we got from JIRA. This could have also been obtained from a schema, if such a schema was available. To spare you the pain of watching me write more code, I will copy paste some prepared code here, but I hope you get the main idea here. And now I need to do the transformation between the change request ID and the issue ID from JIRA. Similarly, I need to transform from a set of issues to a set of change requests. This is called when serving a query request, which naturally returns a number of entries. And here you can see the methods transform resources, which also needs to be implemented. I will also need to do the transformation of the IDs between the queries, because they will differ between the OSLC query parameters and the way JIRA has parameters for its queries. So it's a bit more complicated code, but the idea is the same. Some transformation of the IDs and the URLs is necessary. And finally, I need to do the transformation logics between projects and service providers, because I decided that every project is a service provider. And again, I will need to transform the resource, but also the ID. Now my interface is ready to run. We will put this to the test by integrating our interface with Polarion, which supports standard OSLC capabilities. So let me start the server. And now we go to Polarion. And the very first step is to establish a friendship relationship from Polarion to this JIRA interface. I will enter the root services for the JIRA application, and then I'll have to authorize it. The next step is I need to establish an association between the Polarion project and one or more of the JIRA project. So we will work with this Drive pilot project from Polarion, and we will create an association. But first I need to authenticate with JIRA to be able to access its information. And here I see two projects in my cloud solution, so let's just choose an association with one of them. Once these two admin steps are completed, the user can now create traceability links from a requirement to JIRA change requests. So let's exit the admin process and let's go in and select a system requirement. And here I want to create a traceability link. The relates to association. And here I want to request the delegated UI from JIRA. So now we get the delegated UI This is quite basic and we haven't completed the information in it, but this of course could be completed, and the layout for these previews can be fixed as we desire. And once it's selected, the user or any user, once it's saved, can have a preview of this information, again from information coming from JIRA. I hope you now got an overview on how to use LynxDesigner to provide OSLC capabilities for your engineering application. I specifically showed how it's done for a typical application that has a REST API. But LynxDesigner is more versatile and can accommodate other types of APIs. LynxDesigner is also more than that. It helps you manage your complete engineering environment when it comes to modeling the overall environment architecture, the information model of the artifacts you are sharing across the applications. All this across the life cycle of your environment. We believe that your engineering environment is a valuable asset that needs to be maintained through dedicated tooling and support. If you want to find out more, give LynxDesigner a try, or discuss integrations in general, please contact us.